computer on here. So like I just mentioned, when we're talking about population that grows in an environment where space or food is limited, the graph of the population versus time resembles this particular graph down here in the logistical curve. Like I said, environmental factors begin to show their effect, and the growth rate begins to a steady decline. Over an extended period of time, the population approaches a limiting value, which represents the upper limit. Population curves of this type are called logistical growth curves. And like I just mentioned, that upper limit is also called the carrying capacity. So when we're talking about logistical equations, we're looking at equations in the following form. P of t is equal to L over 1 plus A times e to the negative kt. Again, you do need to know what that logistical equation model is supposed to look like, because you may have to write that particular equation. In this particular equation, some key pieces of information. L, the numerator, is the carrying capacity. So you can tell what the carrying capacity is just by looking at the numerator when you're dealing with a logistical curve in this particular form. K is your growth constant. Notice in the formula, it's negative kt. So when you're talking about the growth constant, the negative sign is a part of the formula. All right? So when we talk about the differential form of the logistical curve, the differential equation for your logistical equation is in the form of k times p times the quantity of 1 minus p over L. Anytime you are looking at the differential form of a logistical equation, you always want to have the differential form written in this particular form. The key pieces of information, again, you can pull out if you're given the differential equation. Again, the coefficient of p, that is your growth constant. And again, you want to make sure that inside the parentheses that you have a term of 1. If that is not a 1, you want to factor out that particular value. The reason why it's critical that you want the differential form of this equation in this form is because the denominator of p in this particular fraction, that is your carrying capacity. Most of the time when you're dealing with logistical questions that they're asking, it's always going to deal with carrying capacity. They're going to ask you about growth constants. They're also going to talk about where it grows the fastest. So like I said, here's an example of what a logistical curve looks like. The carrying capacity, like I said, is in the equation. That is your L value. So at some point on your logistical curve, you have an inflection point. And this inflection point is a very key value. Let's call this particular value A. So at a time t is equal to A, you're going to reach half of your carrying capacity. That's a very key number when you're dealing with logistical models, because another question that they're going to ask you is, when is the population growing most rapidly? It's growing most rapidly at half the carrying capacity. So L over 2. So really there's 3 questions they constantly recycle, and they go back to asking you about logistical curves. 1 is the carrying capacity. 2, your growth constants. 3, they're going to ask you about where the population is growing most rapidly. And that's always at half of the carrying capacity. So those are the 3 things when you're dealing with logistical models you always want to make sure you're able to find. Like I said, in some questions they'll give you the differential form. Some questions they'll actually give you P of t, or the actual function. So you have to be able to pull those pieces of information regardless of either function that they give you. All right, the reason why the population is growing most rapidly at half the carrying capacity is, let's take a look at the differential form of your logistical model. Your dP dt is equal to Kp times 1 minus P over L. So remember how you found inflection points? You found the second derivative and you set the second derivative equal to 0 because you're looking to see where the curve changed concavity. So I'm going to go ahead and distribute the Kp. So I'll have Kp squared over L. So I want to take my second derivative with respect to P. So then the derivative of Kp is just going to be K minus 2pk all over L. And then remember, I'm going to take this second derivative and I'm going to set it equal to 0. So then K would be equal to 2pk over L. So now if I go to solve for P, I'm going to just go ahead and multiply by the reciprocal, which would be L over 2P. L over 2K. So then P is going to be equal to K times L over 2K, or L over 2. So that's where that inflection point turns out to be, and that's why it's growing most rapidly at half of the carrying capacity. All right? So any questions on that? So some couple things, like I mentioned, that you want to make sure you know about your logistical growth curves. First of all, like I just showed you, at half of your carrying capacity, the population is growing the fastest. So L over 2, that's where your population is growing the fastest. And in your diagram, at t is equal to a, which I labeled on the previous graph, at t is equal to a, that's where you have an inflection point. And again, at that inflection point, that's where the population is growing the fastest. And again, that's going to be at half of your carrying capacity when you're dealing with logistical curves. At t is equal to a, the rate of change in population is at its max value. So again, they may not ask you always where is it growing the fastest. They may ask you where is the population rate at its max value. They may ask you about the inflection point. So there's other various ways that they may ask you about where is it growing the fastest. So these are just some common things they may actually ask you in these particular problems. So your favorite, when they ask you about logistical equations, another thing they may ask you is to find the limit as t approaches infinity. So when they're giving you the logistical curve and they want to know the limit as t approaches infinity, that's just simply another way of them asking you about your carrying capacity. And remember, the carrying capacity is also a horizontal asymptote. Which is also its limiting value. So just some other ways they may ask you about carrying capacity without them saying what is the carrying capacity. They may ask you about the limit as t goes to infinity. They may ask you about what is the horizontal asymptote. All right, so just some different ways they may ask you about that L value. The limit as t approaches infinity of p prime of t, and by setting that derivative of p of t is equal to 0, is another way to find the carrying capacity or your horizontal asymptote or the limiting value. So like I mentioned, they may give you the logistical equation. They may give you the differential form of the logistical equation. So you have to be able to answer questions about logistics given whether it's the equation or the differential form. So here's an example where I'm actually going to be giving you the logistical equation. So they're giving you a bacteria culture is growing at a rate of 2.5 divided by 1 plus 0.25 e to the negative 0.5, where y is the weight of the culture in grams and t is your time in hours. So first question, what is the initial weight of the culture? So to find my initial weight of the culture, what do I want to know? I want to know when t is equal to what? 0. These could be calculator. These may also be no calculator questions. So all I'm going to do is I'm going to find y of 0, and I'm going to plug 0 into this equation for t. So 2.5 divided by 1 plus 0.25 raised to e, and again, that's going to be e to the 0 power. So I know it'll be 2.5 divided by 1 plus 0.25. So what is the initial weight of the culture? 2 grams. Again, like I said, could be calculator, could be no calculator. Okay? What is the carrying capacity of the culture? 2.5. There's a problem with this part of the question, part C, so we're going to change part C. We're going to change it at what time is the weight of the culture 2.25 grams. And again, we're going to use our calculator for this part. So at what time is the weight of the culture 2.25 grams? So what variable am I solving for in my logistic equation? I'm going to be solving for what? T. So I'm going to take my 2.25 and I'm going to set it equal to my logistic equation that's given. So 2.25 is equal to 2.5 over 1 plus 0.25 times e raised to the negative 0.5t. How are you going to solve this using your calculator? What are we going to do? Go to your y equals, and what are we going to do? Type in 2.25 under y1. Under y2, we're going to type in the logistical equation, and then we're going to find the point of intersection. So 2.25 is under y1. And then again, you have the fraction bar under alpha y equals. I recommend you using that fraction bar if you have an 84 with the updated operating system. So go under your alpha, y equals, and the very first option you'll get the fraction bar. That way you don't have to worry about making a mistake with parentheses if you're using the division symbol. You never knew that? Nobody ever showed you the fraction bar before. So I figured by now we all knew where that was. So if you hit alpha y equals, you should have this menu pop up. Under option 1, n/d, that's a fraction bar. So now you don't have to worry about making those mistakes with parentheses. See, you learn something new every day. All right? So now I'm just going to type in 2.5 in the numerator, and then the denominator I'm going to type in 1 plus 0.25 times e raised to the negative 0.5t, or an x. And again, you want to find that point of intersection. So I'll go under my second trace, option 5, intersect. And then that's where you do that first curve, second curve guess. So my intersection point is going to be at 1.622. And the time is in hours. So any questions on answering, again, you're given the logistical equation. Any questions on how I answered those 3 questions? All right, let's take a look at another example. We have a certain number of students infected by measles in a certain school. Oh, that's a lovely thing. And again, they're giving me, notice the logistical equation, where T is the number of days after students are exposed to an infected student. So what is the population at T is equal to 0? So what I'm going to do is I'm simply going to plug 0 into this equation for T. So P of 0 is equal to 200 divided by 1 plus e to the 5.3 minus 0. So then P of 0 is equal to 200 divided by 1 plus e to the 5.3. So again, when I type this in the calculator, again using that lovely new discovery of the fraction bar, 200 divided by 1 plus e to the 5.3, 0.993. Now, Is that a reasonable answer? No. Well, and we're not going to round down to 0 students, because if 0 students didn't have the measles, we wouldn't have the outbreak. So we're going to round this answer up. So I'm going to round this answer up to what? 1 student. So 1 student had the measles at time t is equal to 0.
The whole school.
What's the carrying capacity? 200. So there's probably, the school probably only has 200 students in it. So at most, only 200 students could become infected with the measles. All right?
Or the best time or their measles shot.
So let's talk about part C. What is the constant K? Now, this logistic equation is in a little bit different form than the original model that I gave you, because you just don't have the t, you have 5.3 minus t. When you're talking about the constant K is the coefficient of t. So when you're looking at the logistical model, the constant K is the coefficient of t. Remember, the logistical model is L over 1 plus A times E raised to the negative KT power. Remember, the negative sign is a part of the model. So the K value is just going to be equal to 1. So now when you take a look at D, when does the number of students infected reach half of the carrying capacity? So what variable am I solving for in this particular equation? I'm solving for what? T. I want to find T when P of T is equal to half of 200, which is 100, because it's going to be 200 divided by 2, my carrying capacity divided by 2. So you guys go ahead and use your calculators and solve this part for me. The population of the school is 900. That includes students and staff, and the rate of the infection is proportional to both the number infected and the number of students' eyes are pus-free. About 75 people are infected on December 15th, which is day 0, and 250 have contracted pink eye by December 20th, which is day 5. How many people will have gotten the crusty eyes by Christmas Day? So, like I said, obviously this is not an exponential growth or decay because you're dealing with a limited population. What is the limited population in this particular school? 900. So that is your carrying capacity. So in order to write these logistical models, you have to know 3 things. You have to know your carrying capacity, you have to know the A value, and you have to know the K value. So in order to answer the question, you have to have an equation to substitute values into. So for logistical models, there's 3 things you have to know, the L, the A, and the K. So we know that the carrying capacity is 900. So what we have left to do is find your A value and find the K value. So in the problem, they're telling you that on day 0, 75 people had the pink eye. So I know that P of 0 is equal to 75. Then they're telling me 5 days later, 250 people have contracted the pink eye. So I know that P of 5 is equal to 250. So these are the conditions that I'm going to use to help me come up with a logistical model. So the first step is, what I'm going to do is I'm going to find A. Now, if you look at the logistical model, I've got 2 sets of values I can use. So what I want to do is I want to find A first. So I'm going to use the value when t is equal to 0 so I can get this exponent to go to 0. So what I'm going to do is I'm going to take this formula, P of t is equal to L over 1 plus A times e to the negative kt, substitute in P of 0 is equal to 75. So I'm going to take 75, set it equal to, I know my carrying capacity is 900, over 1 plus e to the negative k times 0. oh, excuse me, it should be A right here in front of my E. A times E to the negative K to the 0. Because again, what happens with E to the 0? E to the 0 is just going to become what? 1. So 75 is equal to 900 divided by 1 plus A. So this one I'm going to go ahead and I'm going to solve algebraically, because like I said, these could be calculator or these could be no calculator questions. How am I going to solve this algebraically? Multiply by 1 plus A, so I have 75 times 1 plus A is equal to 900. Divide by 75, so 1 plus A, when I take 900 and divide it by 75, what's that going to give me? 12. So what's A going to be equal to? A will be equal to 11. So any questions on how I found the A value? So now I know L, I know A. My second step is I'm going to find K. So just like I did to find A, I'm going to plug the values that I know into my logistical model. Now again, I've got two different data points to use. I don't want to use my original P of 0 is equal to 75 because remember if I plug 0 in for T, the K value ends up canceling out. So I'm going to plug in P of 5 is equal to 250 into my logistical model. So I'll take 250, set it equal to my carrying capacity, which is 900, divided by 1 plus, I know what A is equal to 11, times E raised to the negative 5K. Again, I'm going to go ahead and I'm going to solve this algebraically, so I'm going to cross multiply, so 250 times 1 plus 11e to the negative 5k is equal to 900. Divide both sides by 250, so 1 plus 11 times e to the negative 5k. 900 divided by 250 is going to give me 18 over 5. What's next? What's next here? Subtract the 1. So I have 11e to the negative 5k. And again, remember when I subtract 1 from 18 fifths, that's 5 over 5, so that's going to give me 13 fifths. What's next? Divide by 11. Remember, before you do the ln of both sides, you want to make sure that you have that base all by itself. So I'm going to divide both sides by 11 or multiply by 1 over 11. So e to the negative 5k is equal to 13 over 55. Now what am I going to do? I'm going to take the what? Now I'm going to take the ln. So negative 5k is equal to ln of 13 over 55. So k is going to be equal to negative 1/5 times the ln of 13 over 55. Okay. Any questions? Again, like I said, these could be calculator or these could be no calculator questions. So you want to make sure you can handle the algebra writing these. Okay. So now that I know L, A, and K, I can start writing my logistical model and I can answer the question. So P of T is going to be equal to 900 divided by 1 plus 11 times E raised to the negative. Again, I'm just going to write this as the K value circled times T. And again, K is the value down here. So now I'm ready to answer the question. So now the question's asking me to find how many people have gotten the gift of crusty eyes by Christmas Day. So what am I going to plug in for T? Because I want to solve for the number of people. So what am I going to plug in? I want to find what? When T is equal to what? 10. So I want to find P of 10. So P of 10 is going to be equal to 900 divided by 1 plus 11 times e raised to that negative k value times 10. Just like we did with exponential growth and decay, store that k value in your calculator when you go to plug them in. Yes, Max?
If this is a calculator question, question. For step 2, can you just plug 250 and the equation in your y coordinates
Yes.
for k?
Yeah.
To avoid all that extra math.
Right, but like I said, I'll tell you right now, when they don't give you the logistic equation, 99% of the time, these are no calculator questions.
Oh.
So you've got to make sure you can handle the algebra to find the logistical model. Yes, Vincent.
This problem relies on you knowing when Christmas is.
Yeah.
All right, so I'll make sure we put December 25th on there next time. So now you guys go ahead, use your calculators, and you can go ahead and find what P of 10 is. How many students? 557 students. Okay? So any questions, guys, if they don't give you the equation, how you're going to have to come up with the equation in order to answer the question. All right? So let's take a look now. Instead of them giving you the logistical model, they're going to give you the differential form of the logistic equation. So we have that P of T denotes the size of a fish population. If the population is increasing according to the logistic curve, where T is measured in months. So they want me to answer these 3 questions. First of all, remember the form you want the logistical equation differential form written in. You want it written in the form of K times P times 1 minus P over L. If the differential form of the logistical equation is not given to you in that form before you even start answering the questions, get it in this form. What's the problem with the form that they're giving you?
There's an 8.
There's an 8. So what we want to do is you're going to factor it out. So you're going to factor the 8 out because you need this number right here to be a 1. So that you can identify your carrying capacity, you can identify that constant rate of growth. So I'm going to factor out the 8. So dp dt is going to be equal to 8p times 1 minus p. Now, when I factor an 8 out, what does p over 1,000 become when I pull out an 8? It's going to become what? P over 8,000. This is the equation you want to look at in order to answer the questions. So it's asking you what is the horizontal asymptote. So what is the horizontal asymptote for this particular logistical model? 8,000. Is there another one? Look at the graph I did on the board at the very beginning of class. It's a trick question, 0. Often forget about the 0. Remember, logistical curves resemble an exponential function in the beginning. So you have, when they ask you about horizontal asymptotes, there's 2. Okay? What is the population at the time when the population is growing the fastest? Well, it's growing the fastest at what? L over 2. So at half your carrying capacity. So my carrying capacity is 8,000, so I know it's going to be what? 4,000. Find the logistical model that has P of T with the initial condition P of 0 is equal to 400. So again, you don't need to do separation of variables. You don't need to do the integration. In the previous example, I showed you how you can find the equation for a logistical model. So P of T is equal to L over 1 plus A times E raised to the negative KT. So when you want to write the logistical model, remember what you need to know. You have to know L, A, and K. The nice part about when they give you the differential form of the logistical model, you're going to be able to know 2 out of these 3 values. We know what L is. What is L equal to? 8,000. What else can we find from the differential form of the logistical model? We can find the K value. And what is K equal to? K is equal to 8. Because remember, the logistical form, that is your K, the coefficient of P. So the only thing you have left to do is to find the A value. So the only thing I have to do now is find A. So if they give you the differential form and they want you to find the logistical model, you only have the one variable to solve for, which is A. So they're giving me the condition P of 0 is equal to 400. So I'm going to take 400, set it equal to, the L value is 8,000, divided by 1 plus A times E raised to that K times 0 power, which is just 0. So 400 is equal to 8,000 divided by 1 plus A. Algebraically, how am I going to solve this algebraically? Multiply 1 plus A. So 400 times 1 plus A is equal to 8,000. Then what? Or you don't have to distribute, you can just divide. What is 8,000 divided by 400? 20. So what's A equal to? A is equal to 19. So now you know your A, L, and K, so now you can go ahead and you can finish writing the equation. So P of T is going to be equal to 8,000 divided by 1 plus 19 times E raised to that negative 8T power. You can, if you really wanted to, you could do the separation of variables and do the integration, but it's much easier to write the equations in this form. All right? So any questions on example 4? All right, last example. So a rumor is spreading through the community at a rate. So notice they're giving you the differential form. First of all, is it in the form that I want? Is it in the form of your dP dt is equal to K times P times 1 minus P over L? Yes. Because again, the denominator of Y is just a 1. So for part A, what proportion of the community has heard the rumor when it is spreading the fastest? Well, what is your carrying capacity? Your carrying capacity is what? 1. So half the community. So again, half your carrying capacity. So part B. If at time t is equal to 0, 10% of the people have heard the rumor. Find y as a function of t. So what are they just simply asking you to find here? They're asking you to find the logistical model. All right, again, what do you have to know? You have to know your A, your L, and K. You have to know this in order to write the equation. Remember, the equation's in the form of L over 1 plus A times E to the negative KT. Like I said, they're giving you the differential form, so you should be able to know what the L and the K value is going to be. What is L equal to? L is equal to 1. What is the K value going to be? 2. So what I'm going to do, and again, they're telling you at time t is equal to 0, 10% of the people have heard the rumor. So they're telling you that y of 0 is equal to 0.1. So I'm going to plug the L, K, and y of 0 is equal to 0.1 into this equation to find A. So now again, I'm just simply going to find A. So 0.1 is equal to 1 over 1 plus A times e to the 0. So 0.1 is equal to 1 over 1 plus A. Tell me what A is going to be equal to. Did you come up with A is equal to 9? Okay. So now I'm ready to find my y of t. So y of t is equal to my L value of 1 over 1 plus 9 times e raised to the negative 2t power. So So any questions, guys, on writing the logistical equation, whether you're given the differential form or in a couple examples ago where you actually had to pull the information out and you had to find L, A, and K all on your own? And then last question is, at what time is the rumor spreading the fastest? So they're asking me to solve for T. Well, I know that Y of T is equal to what when the rumor is spreading the fastest? I know that half the carrying capacity was 1/2. So how am I going to find T? I'm going to have to set my logistical equation equal to what? 1/2. So 1/2 is equal to 1 over 1 plus 9 times e to the negative 2t. So what I want you to do now is I want you to solve this algebraically and then use your calculators. Do it both ways. I see a bunch of you on your calculators ready. Do it by hand first. Yeah, do it hand. All right. And then check it on your calculators. 099 days. So in exact form, ladies and gentlemen, you should have gotten negative 1/2 times the natural log of 1/9. So if this was a no calculator question, that would be your answer to the question. Checking it on your calculators, 1.099 if you were to type this in under Y1 and Y2 and find the point of intersection. Is there another way, ladies and gentlemen, I can express this answer of negative 1/2 times the natural log of 1/9? Using property of logs, don't forget, if this is multiple choice, you're probably not going to see this written as one of your answer choices. Because what is that? Using your power rule, what can I do with the negative 1/2? I can move that to become the exponent for 1/9. So I could also write this as the natural log of 1/9 raised to the negative 1/2 power. Well, with a negative exponent, what would I do? I would take the reciprocal of 1/9, which is 9 to the 1/2. And what is 9 to the 1/2? 3. So you would probably see this answer on a multiple choice test. So be careful when you're dealing with these LN questions. A lot of times they're going to use all those property of logs to simplify. All right? So any questions on that? All right.